Our essential questions have been, how could we use trigonometry and trigonometric ratios to find missing angle measurements and to find missing side lengths? And so we've been working with triangular features, and especially your right triangular patterns, and looking at how they play out in real life. And so here we have a typical situation where you either look up at something or you look down at something. And so when we talk about these angles that are formed with your line of sight, we can refer to them as your angle of elevation or depression. Now your angle of elevation, so let's say you are here on the ground, you're looking up at the airplane, that is measured from your line of sight to where your typical line of vision is when you're just looking straight ahead. So this horizontal line here is if you're just looking straight ahead, and then up to the line of sight where you're looking at the airplane, that's what we refer to as your angle of elevation, because you are elevating, you are turning your head and looking up at the object. Now, if you were the pilot of the airplane and you're looking at something on the ground, that's your angle of depression, again, because normally you'd be looking straight out ahead of you at your horizontal line. And then if you're depressing your head, looking down at the ground, that is the angle that's being formed with your line of sight. Now notice that when you're just looking ahead, the horizontals, these have slopes of 0, right? And so we refer to these as your parallel lines, right? The horizontals are parallel for the pilot and for you on the ground. And the line of sight for both of you is forming the transversal of those two horizontal lines. Well, what kind of angles are being formed with the angle of elevation and depression? Those are now alternate interior angles. Again, because these horizontal lines with the same slope, they're parallel to each other. Here's your transversal, cutting those two lines, right, intersecting them, forming the angles, and we have a pair of alternate interior angles that are congruent. So an angle of elevation and an angle of depression are congruent to each other. That's helpful when we're setting up and solving our problems, depending on where our perspective is for the angles. So let's take a look at an example together. So here you've got a ground crew worker who is 6 feet tall directing a plane on the runway. The worker sights the plane at an angle of elevation of 32 degrees. What would be the horizontal distance from the worker to the plane? So our worker here for the ground crew that's 6 feet tall is here, again looking up at the plane at 32 degrees. Here's your angle of elevation, because typically you would be looking straight out ahead of you, right? There's your horizontal, and up at the object he's directing to land that plane. So there's your angle of elevation of 32 degrees. What else do we know? We know that the plane is currently 150 feet above ground, and we want to know the distance horizontally the plane is away from the ground crew worker. So remember how we were doing our problems before? We can see there's a right triangle being formed, right? And we were labeling where we were standing for a point of reference, what's opposite, adjacent, your hypotenuse, and that helps us to determine what trigonometric ratio we could use to help solve the problem. So let's do the same thing here. If you guys could move your person where the ground crew worker is and label your sides, what's opposite, adjacent, hypotenuse, to figure out which ratio to use. We'll check and see if you're on target. So again, here's our ground crew worker. We can see that opposite the ground crew worker is 150 feet. That's the height of the plane above the ground. Our hypotenuse would be the way the plane is going to land on the runway, being directed towards the ground crew worker. And we have our adjacent side. Now, what do we know the most about? Well, we have the opposite length, and the adjacent length is what we're looking for. That's x. So what ratio uses opposite and adjacent? Well, that has to be your tangent ratio. So now we're going to fill in what we know. The opposite side, again, was 150 feet. The adjacent side is x, and the angle that we're working with is 32 degrees for the tangent. So again, we were talking about writing our proportions, right, to help us solve using our means extremes theorem. So x times the tangent of 32 equaling 150 times 1, which is 150. We're trying to solve for x. So again, we're going to undo this multiplication of the tangent of 32 by dividing each side by the tangent of 32. So these make a 1, having x equaling to this ratio. So we can grab the calculator to help us do that. 150 divided by the tangent of 32, and let's round to the nearest tenth. that would be about 240.1 feet. So the distance the worker is for the ground crew away from the plane horizontally is about 240.1 feet. So again, what were the keys to this problem? One, where are you standing at? Where's your point of reference? So the ground crew worker here. Labeling your sides based on that perspective. So what's opposite, adjacent, hypotenuse. Figuring out what ratio to use, and then substituting into the ratio to help you solve for the missing piece. Whether in this case it was a side, but we also can work on using the information to help us find angles as need be. So again, to recap our important vocabulary, talking about angle of elevation, that's your point of reference. So if you're standing here at the cabin, looking up at the top of the Again, it's from your horizontal, where you're normally looking straight ahead of you, up to the top of the cliff. That's your angle of elevation. Now again, if you change your perspective and said, okay, well, what if I was standing at the top of the cliff and looking down at the cabin? Again, horizontal down to what you're looking at, that's your angle of depression. And those two angles would be congruent because they're alternate interiors with those parallel horizontal lines. And again, here's another example of your angle of depression. If you're standing at the top of the lighthouse looking down at the buoy, again, your horizontal down to your line of sight, that would be your angle of depression. Let's take a look at another problem. It says the peak of Goose Bay Mountain is 400 meters higher than the end of a local airstrip. The peak rises up above a point 2,025 meters from the end of the airstrip. The plane takes off from the end of the runway in the direction of the mountain at an angle that is kept constant until the peak has been cleared. If the pilot wants to clear the mountain by 50 meters, what should the angle of elevation be for takeoff to the nearest tenth of a degree? So again, what we want to do is look at our givens and label our picture. So again, the pilot would be here in the plane. And if he's talking about clearing the mountain peak by 50 meters, right, we have to think about, well, how much clearance is that above the ground? Well, from the ground level to 50 meters above, that's 450 meters of clearance vertically we need to have for the airplane. And we know that from where the plane is right now to the peak of the mountain clearance that we're trying to reach, it's 2,025 meters. So if we start labeling our picture like we did before, where we're standing, our opposite, adjacent, hypotenuse, that will help us figure out what ratio we need to solve. So if we start moving our items into place, again, here's the pilot. The mountain peak we're trying to clear, that's our opposite. Our horizontal distance here is the adjacent, and then we have our hypotenuse here. And the triangle we're going to focus on is our triangle with points C, D, and A. Okay, so we're going to focus on that outer triangle. So what do we know the most about? Well, we know the opposite side is 450 meters. We know the adjacent side is 2,025 meters. What ratio are we going to use? Well, opposite and adjacent, that would be our tangent ratio. So again, if by filling in what we know, we've got our opposite 450 meters divided by our adjacent 2,025 meters equaling the tangent of our angle, which is x, our unknown. So we have to undo the tangent ratio to find the angle measurement for x. So remember, when we undo things, we use their inverse operations. So if we have the tangent, we have to take the inverse of tangent for each side of our equation to find the angle measurement of x. So the inverse tangent and tangent, they undo each other. So we just have x on the right-hand side. And then we just have to do the calculation on the left-hand side. So if I take the inverse tangent of 450 divided by 2,025, approximately we end up with about 12.5 degrees. That is the angle of elevation our takeoff needs to be in order to clear the mountain peak. So we've gone through examples of how you could find a missing length. We also went through how to find an angle measurement, and we're going to do more practice with those again today.